What are stars made of? Sounds like a difficult thing to answer because they're very far away. But chemistry can give us answers. So, let's work out how to read the stars. Aprendamos a leer las estrellas. This is Real Chem. Básicamente, atoms absorb electromagnetic radiation, which causes electrons to jump. When they fall back into place, they emit radiation that is quantized. This is quantum chemistry. Let's use the hydrogen atom to think this through together. Exploremos. When an atom absorbs light, the electrons in the atom get excited to a higher energy level. They jump like a kid that has eaten too much sugar. I know this because I have a toddler, and as fun as it sounds, you don't want to meet them after a sugar crash. Let's say we shine white light on an atom. White light is a mix of all the colors of the rainbow. But the atom doesn't absorb all of these colors. It absorbs only light from very specific colors. The absorption spectrum of an atom shows these colors as black lines. But what makes an atom so picky about the colors it will absorb? Well, part of this has to do with the atom, and part of it has to do with the light. Let's start with the light. Light consists of photons, and the energy of a photon is related to the color of the light. Red photons have low energy. Violet photons have high energy. So the atom is picky about the color of photons it absorbs because it can only absorb photons that have very specific energies. But what makes the atom so picky about photon energy? Well, electrons in an atom can only have very specific energies, which we call energy levels. When an atom absorbs a photon, it transitions from a lower energy level to a higher energy level. The energy to make this transition comes from the photon, and the photon must have exactly the right amount of energy, no more and no less. If an atom absorbs an orange photon, it's because photons of the color orange have exactly the energy needed to move between two of the allowed energy levels in that atom. Atoms can also emit light. This occurs when the atom starts at a higher energy level and drops to a lower energy level. The color of the emitted light is that of photons whose energy corresponds to the gaps between these energy levels. Each element has its own unique set of allowed energy levels. Hydrogen levels are different than helium levels. This means hydrogen and helium will absorb and emit different colors of light. So they have different spectra. We can use the spectrum to identify the presence of different elements. It's as if the spectrum is a fingerprint, telling us the element is there. If we see the spectrum of helium when we look at a star, it means helium is present around that. Telescopes that measure spectra allows us to read the light emitted across the universe and unravel what distant stars are made of. Bastante interesante, ¿no? So explore and remember to have fun. Explora y diviértete.